Last class I have started dimensionings in orthographic projections. So, completed few thumb rules, or you can say that few principles in dimensioning. Now, arrangement of dimensions, two basic styles, chain dimensions and parallel dimensions. You can do in a chain dimensioning, you can do in parallel. Also combined style also it is possible, means both chain as well as parallel dimension you can do it. And most appropriate view, ensure the clarity and proceed with phi to distinguish from the length. Suppose this is a view, I have explained, just review it. If this is a view, that means this phi, that means the drill diameter, it should be proceed with phi to distinguish from the length. That means it should be first, then your other length will be come forward. So, here it is phi, this is a drill up to this, then there is a phi, this is a entire drill up to this phi. Phi is your nothing but a drill diameter. Then arc of circles proceed with r to distinguish from the length. If you look at here, this is your length, that means this surface to this surface, this is your length, that means this is your 250 mm. This is one arc, this is another arc, that means from here, from the center point I have taken a line from here r 30, that means radius of this arc is your 30 mm. As I said earlier, the dimensions are in mm unless otherwise if it is not specified. Here similarly r is equal to 100, that means radius of this arc is 100 mm. Dimensioning, once there is no space is not available, you can do this way, smaller spacings. Here it is a dimensioning, if a 3 degree 0 minute 45 second, here it is very difficult to do dimensioning inside. Here you can make it 2 arrows, then from this arrow you mark it, here you write it 3 degree 0 minute and 45 second, that means dimensioning in limited space. Enlarged view, up to this I have covered. Enlarged view means if this is your view, complete view, in this view this part you have to enlarge it because this is a complicated one, then enlarge it and show the gap, show the depth dimension, show the width dimension inside this, and what is this, you explain it. That means you mark it here, then take it here outside, enlarge it, enlarge at section AA and give dimensioning so that it will be clear to the manufacturer and he can easily read these dimensions of this view at A or section at A. Now start with these examples, few examples, 2-3 examples. Two styles, first one we are talking about chain dimensions, arrangement of dimensions. This is the same view I am putting it here. Look at here left hand side and right hand side. Once you start with a chain dimensioning, that means if it starts here, it will continue in the same line. If you look at here, I am putting it here at the top for this dimensioning, putting at the bottom. Here top, bottom, bottom, top, there is no alignment, hence this dimensioning is wrong. This way of dimensioning the view is wrong. Again another thing you can mark it, another thing as I said, how you do the dimensioning, as far as possible do only 2 sides, do not do all the sides. Though I have marked it here, as far as possible here you have, it has been, the dimensioning has been done this side, that means as far as possible you remove this side and this side. For clarity, cleanness, a view has to be dimensioned only considering 2 sides. So comparing this same view, this part of the dimensioning is correct because this chain dimensioning is consistent, but here there is no chain dimensioning. As I said there, do not provide too many dimensions. As I said there, one is your 2 sides, second part is your do not provide too many dimensions. If you looked at here particularly in this case, this side view here, we are providing the dimension here, here, again here, again here. There are many dimensions are there. It is obvious if I provide these two, then easily if the total dimension, if you know from here to here, if I provide these dimensions, obviously I can calculate these dimensions instead of providing these dimensions separately. So too many dimensions you avoid. So in this way, dimensioning, particularly this view, is wrong and this is correct. Choose appropriate location, positioning, dimension of the positioning, you choose the appropriate locations. If you look at these appropriate locations, that means suppose there is a, this is a view, there are 3 examples, 1, 2, 3, this is a view. If you looked at this view, means this diameter, this hole or this circle, it is where? It is this side. You can dimension from this side, it will be better. That means appropriate position. I can do the dimensioning also from here to here, right? Appropriate position is the best one. Then here if you looked at here, here there is one arc. If you take arc from here, this side, and put it here, I can also make it outside, I can put it here also, this is correct. You cannot take it out here and show it. Then here there is a phi, there is a drill. If you look at, there is a hidden drill inside here. Then in this view, you can take from the center line, here it is a center line, take it out, phi is equal to g. G is dimension, it may be 20 mm or 30 mm. This is all about your course orthographic projections and dimensioning. So next part I am going to start it, isometric projections. Isometric projections, second chapter. Then in this isometric projections outline, basically we are going to discuss isometric projections, isometric drawing versus isometric views, and few examples. 3-dimensional clarity, relative positioning of overall size, relative positioning and sizing of constituent parts. What is the need? Need for isometric is, I can put the subject in such a way that, so that 3-dimensional clarity will be there. I can see 3-dimensional, all sides I can see, I can rotate, I can put the object in such a way that I can see the front, I can see the side, I can see the rear view. Realistic feel, it is necessary, isometric view, to assemble parts. Any scooter, any motor pump, it has to be joined together. How to assemble? You can separate it out, then looked at in a different position, rotate it, so that 3-dimensional view you can see it. Then you can assemble this object, so that as a whole this manufacturer can set it. This is the need for isometric projections as well as isometric view. Theory of axonometric projection. What is axonometric projection? Looked at here very carefully. Now this is a plane of projection. See, there are 2 views, one is this view, front view is there, in the front view, rear view is there, then there is here is side view is there. This is a plane of projections. I am seeing this projection on this plane. Come to this object has been slightly rotated. Look at this object, it has been slightly rotated. Once it has been slightly rotated, I can see this face as well as top, side, front as well as some part of the top face I can visualize. But here in this object, I can visualize most of the part of the front, side it is not clear and top it is not clear. Now in this way, if you look at the plane of projections, how it looks, I project it back, how it looks. Here the moment I project it back, the projection is only the face. Here the moment I project it back, face, side as well as some part of your top surface. How it looks. Here it is front face, but here it is the face which I am visualizing. That means 3D view, three surfaces I am visualizing and it has been projected. Now again this, there is 3 distinguished, try to understand. This is a simple object, it has been viewed in the one side or one face. then same object has been rotated slightly with respect to vertical axis. With respect to vertical axis it has been rotated. Then here with respect to profile plane or side view it has been rotated. Here it is rotated with respect to vertical axis, here it is rotated with this profile. There is two difference. With respect to vertical, that means same object has been rotated with vertical, here same object has been rotated with your side profile plane, here it has been rotated with your profile, here it has been rotated with respect to your vertical axis. Now mark the difference. Axonometric projection is theoretically orthographic projection in which only one plane is used, the object being turned so that three faces show. It is basically you can say extension of orthographic projections. Only difference is that it has been rotated with respect to certain axis as well as certain view, so that I can visualize three faces. If you looked at here, here I can visualize only one face very clear and predominantly. Here if you looked at, I can predominantly see this view and as well as this view, some part of your top view, top face, not top view, top face. Here if you looked at, I rotate it with respect to your side view. With this axis it has been slightly tilted. Then what happened? This face I can see, this face I can see, predominantly top surface also I can see it. Now plane of projection I bring back how the projection looks like. Orthographic, only one face. Plane of projection I rotate with respect to vertical axis, I rotate it with respect to what? With respect to your side view, profile plane, I rotate it. Then plane of projection how it comes looked at here. So basically it is an extension of orthographic projection, only object has been rotated so that I can or object three faces can be easily viewed. Multi-view versus axonometric projections. If you look at here, this is your multi-view projections, means use line of sight here from infinity, that means multi-view means you are looking at here, then you are looking at here, then you are looking at here, then you are looking at here, that means front, top as well as side, but here you rotate it, you are looking at here. That means with a single rotations, slightly rotating you can visualize three faces. Previous discussion centered on 2D orthographic projections. Focus now on pictorial drawing which look more like a picture or more like pictures. It is a basically pictorial drawing. The picture should be produced as a picture. Picture should not be produced as a front view, top view and side view. Picture should be look like a picture should be produced. Easier to why the picture should be produced like it is basically used in mechanical and as well as automobile and aerospace engineering, even if civil engineering also. Easier to visualize the design. The moment you design is so that what is the front face, what is the middle, what is the side, what is the top side, is there any notch, whether this notch is throughout or some part hole will be there, is there any drill, the drill is throughout or part of the view is only drilled. Easier to visualize the design. Relative proportioning of overall size, this is more important. First important is it is very easy to visualize how you proceed for design. Then relative proportion of overall size, how its size is, comparing the top, bottom as well as side, how the size is varying, whether the size is consistent throughout or size is somewhere else it is not consistent or different size throughout the sections. Relative position and sizing of constituent parts, different parts. If I take out different parts, suppose if rotate it, then I can see part 1, part 2, part 3 has been assembled. Then these different parts, what is this constitute, what is their size? Good for marketing, showing assembly, and basically conceptual ideas will be cleared. Basic concept will be cleared in this view. Not good for dimensioning or manufacturing, not good for dimensioning or manufacturing, cannot show the details, cannot show the detail unless if you are not seeing front and top as well as back view, you cannot show the details, so not good for dimensioning. This is your overview of isometric projections and isometric views. Isometric assembly, As I said, simple example, there is a machine assembly. This is your part 1, this is your part 2, this is your part 3, part 4, part 5. I rotate it in such a way that my viewing direction is in this direction or maybe in this direction, it does not matter. Rotate it in such a way that standing it here or standing it here, I can visualize this side, how the assembly, this part, what is its size, or is there any hole, is there any notch, even if there is a knot and bolt, how the knot and bolt look like, even if there is welding, how it looks like, and top face will look like. Isometric drawings are frequently used to show how parts assemble as in this automobile power module, particularly in automobile, how part has been assembled. Axonometric views basic concept, look at this, parallel to picture plane. What do you mean by parallel to picture plane? A picture plane is there, object is there, it is parallel to picture plane. That means only that side, one face you can see, only one face you can see, that is your front view. Rotated about vertical axis, as I explained before two slides before, rotated about vertical axis. With respect to vertical axis, it has been rotated. I can see two faces in the front view. Parallel to picture plane, only one face I can see in front view. Rotated about vertical axis, I can see two faces in front view. Rotated about profile axis, as I said, I can see three faces in pictorial view. That is nothing but your axonometric view. Rotated about profile axis, I can see three faces. Here I can see two faces, here I can see one faces. This is your basic concept. One may get many pictorial views depending upon the angle of each rotation. Try to understand. This I have not defined yet. Depending upon angle of rotations, one may get many pictorial views. Here you are getting three faces. It may possible I can rotate so that I can get five faces also. Such a way that some sort of uniformity and standardization is required, particularly axonometric views. Let us see what is there. In a 3D picture, in a wooden plank 3D picture, this is a picture plane. You are viewing from here, picture plane, the picture has to be seen in the back side. Object is placing here, look at here. Object is placing here, a cube is placing here, and parallel to the picture plane. Parallel to this is a picture plane, this object is parallel to the picture plane. That means only this face I can see in the front view. Front face I can see in the front view. It has been rotated with respect to vertical axis. Vertical axis is nothing but what? This is your vertical axis. With respect to vertical axis, it has been rotated, right? So then parallel to your picture plane. This is your picture plane, these rays are parallel, this view is parallel, then there is a rays. Then you are getting this view and this view. Why you are not getting this view? This will merge. This will merge these points. So you may not get this view. So you will get this view as well as this view. Then rotated with respect to profile axis, slightly tilted. Rotated with respect to profile axis. This view we can see, this side you can see, as well as top you can see. Look at here. Project it back, project it back, project it back. This is called axonometric view in 3D. I have shown it in a wooden plank, wooden bus with a picture plane and object. Just see it. First position, one face seen. First position, one face seen. Rotated about vertical axis by 45 degree. This is the standardization. I said you can rotate it at any angle. You can rotate it at any angle. Depending upon your angle, these views will be different views will come. So rotated about vertical axis by 45 degree. Now this is by 45 degree. Q is there, rotated about vertical axis, because this vertical axis here, it is rotated about your vertical axis 45 degree. how your front view as well as side view it looks like, it is there. The same cube, it is a SRUT, how it looks here, it is a. Then rotate about profile axis. First it is there, it has been rotated about vertical axis with the cube 45 degree. Then you see these two faces. Then with respect to that, rotated about profile axis. The cube has been rotated, then tilted about the profile axis by 35 degree. How the standardization come into picture? Then you can see your three faces. This concept once you understand, there will not be further problem for your axonometric or isometric views later on or isometric projections later on. If you looked at here, projections are still orthographic. What is your orthographic? Very first class I say. Projection lines are parallel to, they are not merging at one point, rather they are parallel. They are here, they are perpendicular. With respect to this plane, these projection lines are perpendicular, orthogonal to this. That means still these three views are orthographic. What these rotation have done? If you looked at here, rotation have done SR, RU, RT. SR, RU, RT. This is SR, RU with respect to vertical, then RT with respect to profile. All what additional you get it by doing this rotation at this here, one face seen, that means you will get the true length. The moment this is parallel to this, that means what is this length, this is your true length. Now the moment you rotate it 45 degree, then by rotate tilted it 35 degree, all foreshortened but by equal lengths. If the angle is fixed, what happen? If you take a different angle, what will happen? Maybe foreshorten in not appropriately, equally. But here with this angle, all will be foreshortened equal length. Suppose this length is foreshortened and this length is foreshortened, it is equally. If it is by 0.5, it will be 0.5. Three mutually perpendicular edges SR, RU and RT. If it is your RU, that means RU is going down. This is your RU is going down. RT, this is your side, SR. Now make equal angle of 120 degree with each other as called isometric axes. After doing this, after rotating 45 degree, then tilted 35 degree, SR, RU, RT. SR, RU, RT. These are making an angle of 120 degree. These are called isometric axes. These are called isometric axes. This is a primary definition, it starts, makes an angle 120 degree. These are called isometric axes. Isometric view, this standardization is different in different axonometric view. In isometric view, the object is rotated by 45 degree about the vertical axis. Remember the standardizations. In isometric view, here it is not isometric projection. Isometric view, the object is rotated by 45 degree about the vertical axis. About the vertical axis, it has been rotated by 45 degree. Then 35 degree, 15 minute, 52 second about the profile axis. 35 degree, 52 minute, 52 seconds about your profile axis, and about the vertical axis it is 45 degree. Why? It results in why you are doing this? Because as I said earlier, it has to be standardized. It results in equal amount of foreshortening of the object along the isometric axes. Isometric, what are the isometric axes? SR, RU, RT. This is your three isometric axes. With respect to isometric axes, it will be equally foreshortened. That means length, width and depth directions, it will be equally foreshortened. So, it results in equal amount of foreshortening of object along the isometric axes. So, in isometric view, in summary, the object is rotated by 45 degree about the vertical axis, 35 degree 15 minute 52 second about the profile axis, and why? The answer is it results in equal amount of foreshortening of the object along the isometric axis. So, tomorrow I will start concept of isometric projection, isometric view, taking it into one object example as an example. I will stop it here. Thank you.